Course assignment, Human Factors in AI by Duke University in Coursera. Reshaping orders backlog management with machine learning. Monday morning chaos. Sales teams scramble for updates about their hardware orders, back office drowns in spreadsheets, clients seeking confirmation of the delivery dates. Sound familiar? Backlog management today is a whirlwind of disconnected tools and constant firefighting. The process is fragmented across sales, plant, logistics, and vendors, often using emails and spreadsheets. The result is lack of visibility and no shared prioritization. The key task here is deciding which customer orders to prioritize so deadlines are met. Today, managers check the backlog, review capacity and logistics, spot delays, decide what to expedite, and sometimes even contact customers to renegotiate. The problem is that this process is fragmented and time-consuming, with managers spending more time searching for risks than solving them. The insight is that machine learning can simplify this by automatically flagging at-risk orders and creating a clear hot list, so teams can focus on taking the right actions instead of chasing information. Our ML model creates a real-time hot list of orders at risk. It generates a dynamic calendar, applies business rules like customer-required dates, risks of loss, and shares priorities across all teams in one place. Leaders can analyze the model predictions and start to take actions. With machine learning, the agent detects patterns and predicts potential delays. It suggests expedite actions before issues arise. No more firefighting. Operations and costs are under control. The predictive model analyzes order data, vendor lead times, delivery urgency, and backlog history. It forecasts which orders are at risk of delay, so managers can act before the issue happens. Instead of firefighting, they can drive proactive decisions. The user experience is simple. Users see risk scores, get explanations on what's driving them, and can identify what orders should be prioritized, renegotiated, or expedite. Managers can analyze details before deciding what to do. Our system collects operational data like order details, delivery dates, and vendor information. Even though this is business data, it can include customer-related details such as names and addresses. The main concern is that this data could be misused if not protected properly. To address that, we limit its use only to predicting delivery risks, keep it secure, and set retention rules so data isn't stored longer than necessary. We will apply local privacy rules depending on where the customer is located. These laws require us to be transparent about what we collect, explain how it's used, give users rights like access and correction, and make sure we have strong safeguards in place. So overall, our approach is to build the system with privacy by design, making sure compliance, security, and user trust are built in from the start. First, on sources of bias. The main risk is representation bias in the training data. For example, if past delays are overrepresented in certain regions, plants, or customer types, the model could unfairly flag those groups more often. There is also a risk of historical bias, since the data reflects past processes and decisions that might not represent current priorities. Second, on the 3 goals of ethical AI. Fairness. We'll monitor predictions across different customers and regions, balance the data set, and test results to ensure all groups are treated consistently. Accountability. A clear team will own the model's outputs, and users will have a process to report issues or errors. This ensures someone is responsible for fixing problems, not just the AI system running unchecked. Transparency. The model won't be a black box. Users will see the key factors driving each risk score, and instead of a simple late or not late, the system will communicate uncertainty, like showing a 70% risk of delay. The benefits of applying machine learning to backlog management go beyond just automation. Yes, the system automates repetitive tasks like scanning orders and generating risk scores, which reduces delays and cuts down on manual work. But more importantly, it augments human decision-making. Managers get clear insights on which orders are most critical, so they can prioritize production, adjust logistics, or even negotiate new timelines with customers. This combination of automation and augmentation leads to smoother operations, transforms backlog management from a burden into a proactive process, and ultimately enhances customer satisfaction.